Start recording. Okay, today we talk about chapter 4, sequence and series. Okay, the sequence and series here we have two sections. So one is a first part sequence series, the second one is a binomial expansion. Okay, first of all, you need to know what is sequence and series. So what exactly is a sequence? A sequence is a group of number that are arranged according to a certain pattern. So we have a 1, 1, 1, 1, 1. So you can see that following the pattern, you should able to tell what is the next value. Through logical thinking, since the previous all are 1, 1, 1, 1, 1, you should able to identify the following number should be 1. For a second example, 1, 2, 3, 4, 5. Same thing through logical thinking. You should able to figure out the next number is 6. And the third example, we have a 1, minus 1, 1, minus 1, 1, minus 1. Similarly, you should able to figure out the next number should be a 1. And for the fourth example, 1, 2, 4, 1, 2, 4, 8, 16. Okay, you should recognize that there is a multiply by 2 from the previous number. Okay, multiply by 2 from the previous number. So therefore, your 1 times 2 become 2, 2 times 2 become 4, 4 times 2 become 8, 8 times 2 become 16. Therefore, the following number, 16 times 2 become 32. The next example, we have 1, 4, 9, 16, 25. So for 1, 4, 9, 16, 25, you should aware that these numbers, they are quadratic number. They are square number. Therefore, this is a quadratic sequence. Okay, so 1, 4, 9, 16, 25, the following number should be 36. Then the last example is not so obvious. Okay, it's actually adding of the previous two numbers. So 1 plus 1 equals to 2, the 1 plus 2 equals to 3, 2 plus 3 equals to 5, 3 plus 5 equals to 8, so on and so forth. So over here, each of these has a name. Okay, this one is a uniform. This one is arithmetic. This one is alternate. This is a geometric. This is a quadratic. This is a Fibonacci. Okay. Of course, there are many group of numbers that can arrange to a different pattern. Okay, but this is just to introduce to you some common one that students actually can understand how does the sequence and series work. Okay, so sequence is a group of numbers in arranged according to a pattern. So what is a series? So series is the sum of the numbers as well, the sum of the sequence itself. So from the earlier we have 1 plus 1, 1, 1, 1, 1, 1. So you become 1 plus 1 plus 1 plus 1 plus 1. So we have 1, 2, 3, 4, 5. Now become 1, 2, 1 plus 2 plus 3 plus 4 plus 5. And so on and so forth. Okay, so this is a series. Okay, series means in the form of plus. The keyword here is plus. The sum. Then for your syllabus, you are required to understand AP and GP, so which is arithmetic progression and geometric progression. So what exactly is arithmetic progressions? Okay, a sequence that fulfill the following term equals to the previous term plus a common difference. Okay, so if we look at the example, okay, so I have a 1, 2, 3, 4, 5. Okay, well, for the next term, the following term, 2 is the previous number adding by 1. The 2 to 3 is adding by 1. 3 to 4 is adding by 1. 4 to 5 is adding by 1. Therefore, this is a arithmetic. But If you look at 1, 2, 4, 8, 16, you will see that this is adding by 1, but this is adding by 2, this is adding by 4, this is adding by 8. The numbers, they are different. Okay, this is not arithmetic progression. This is arithmetic progression. So far so good? Can follow?
Yeah.
Okay. So as mathematically, this thing here, we will write it as, in the mathematical form, Tn plus 1 equals to Tn plus T plus D. Okay, the n plus 1 and the n here means the positions of the term. Positions. So when we write our sequences, okay, when we write our sequences, we write as T1, T2, T3, T4, T5, and so on. So the 1, 2, 3, 4, 5 is actually their position. Okay, so the n and n plus 1 here is just the way to express the relationship between the neighbor terms. Okay, so we have Tn like this. Then from here, what's going to happen? Okay, properties of AP. Okay, properties of AP. So I have T1 equals to, let's say I set it as A. Okay, let T1 equals to A. So according to the formation, I will have T2 equals to T1 plus D. Okay, T2 equals to T1 plus D. So T1 is A here, then hence I can write it as A plus D. Okay, T3 equals to T2 plus D. Where is this coming from? It's all come from here, isn't it? The position, how actually we write the sequence itself. Okay, and the T2 you already know that is A plus D, therefore it's A plus D plus D. Hence I have A plus 2D. We write a little bit more. T4 will be read as T3 plus D. T3 is, we already know that's A plus 2D. So A plus 2D plus D. Okay, so in the end I have A plus 3D. But through observation, you observe that when it's 2, it gives you 1D. When it's 3, it gives you 2D. When it's 4, it gives you 3D. Therefore, if we want to generalize the formula, we realize that Tn over here, for the n term, the value at the n position will be equals to A plus n minus 1D. Do you agree?
Yes.
Okay. Therefore, over here, we say this as the general formula of AP. Okay. So when during exam, we actually use all of these different formula that in box, okay, to try to tackle the questions. Okay, number 5. Sum of AP. Sum of AP. Okay, so the sum of AP here, the standard notation that we write for the sum is Sn. What does it mean by Sn? Sn here means is the summation from the first term all the way to the n term. This is what it means by Sn. From the first term, you sum up to the nth term. Okay, this is the standard notation. According to what we have above, the Sn here, the first one is A. The second is A plus D. The third one is A plus 2D. If we follow the form, we realize that Tn minus 1 here is A plus n minus 2D. And Tn here is A plus n minus 1D. Okay. Let's try to observe how can we actually sum this thing. Okay. Let's try to observe how can we sum this thing. So I'm going to reverse the order. So the one at the back I will write in front. Okay, for the second. And for the third one, all the way until the final two. So what's going to happen now is I'm going to sum these two lines together, but I'm going to sum them vertically. Okay, I'm going to sum them vertically. So these and these sum together, I have a 2Sn. These and these sum together. Okay, I have a 2A plus n minus 1D. Okay, so A and A here. And these and the second position, I sum them together. Okay, I will have A plus A, 2A, D plus n minus 2D, I will have n minus 1D. Okay, these and these together, I sum them up. So I have a plus A become 2A. 2D plus n minus 3D, I have a n minus 1D. All the way. A plus n minus 2D plus A plus D. Okay. So I have 2A plus n minus 1D. And the last one, AA. Okay. Forgot to bracket them together. This one, the last one. Okay. I have a and A, 2A plus n minus 1D. Okay. We'll realize that when I sum them like that, all of them have the same thing. But how many same items do I have here? Since we have summation from the first term to the nth term, we have total of n terms over here. We have total of n terms over here. Therefore, we have 2 as n equals to n times 2a plus n minus 1d. Since we only need to find Sn, so I bring the 2 over to the other side, because it become n over 2, 2a plus n minus 1d. This will be the summation formula for AP. Okay. So you maybe wonder, why do I actually write like this to you? Okay. Because during exam, this they can question, P1 exam can ask for proof. So they ask you to demonstrate the proof, which means you are required to demonstrate exactly the same thing as what I presented here. Okay. So this will be the summation. Okay. Then after this, 1, 2, 3, 4, 5. Okay, so this will be the summation formula. Now let's look at example first. Okay, let's look at example. Let me try to look at example. Example. Okay. Let's try to look at the questions. Okay. Now let's try to write out other informations given by the questions. Okay, according to what we have here, it says the ninth term of an AP is 22. So we can write T9 equals to 22. And the sum of the first four term is 49. Then we can write as 4 equals to 49. Find the first term and the common difference. Okay, which means they are asking for what is the value of A and what is the value of D. So according to the formula, let's try to write them out. Okay, the formula. So the Tn formula is A plus n minus 1D. The Sn formula is n over 2 to A plus n minus 1D. So all I need to do is just write it out. So I have A plus 8D. Then over here I have 4 over 2 to A plus 3D. Okay, so I just write it according to the formula. So since this is 9 here, then I have A plus n minus 1D. Since this is a 4 here, I have n over 2 to A plus n minus 1D. So we have the two equations. So what you will see is this and this is actually a simultaneous equation. The first equation that we have is A plus 8D equals to 22. The second equation that we have is this one simplified 2. So I have 4A plus 6D equals to 49. So all I need to do is solve the simultaneous equation. Can you solve the simultaneous equation for me? Press the button or do it manually. Tell me what you get.
Is it 10 and 3 over 2?
Okay, you have 10 and 3 over 2. So A equals to 10, D equals to 3 over 2. 3 over 2 or 1.5. Okay, so you can see that the question is actually very straightforward. It's all relying on your previous topic, your basic, back to chapter 1, algebra. Okay, we can see that this is a simultaneous equation. So what you need to do is just solve the simultaneous equation. The second part of the question says, the n term of the progression is 46. Find the value of n. So we're trying to write the construction. Tn equals to 46. Write out the formula. I have A plus n minus 1, D equals to 46. You should realize that this is a continuous question. Okay, you will need the A and the D that you found earlier. If your A and D that you found earlier is wrong, of course, the part 2 of the question will be jeopardized. So, okay, since this is 10, so I put 10 here. Then I have an n minus 1 here. Then I have a 1.5 here equals to 46. So I rearrange the work and trying to figure out what is the value of n. Trying to do the calculation. Let's see what do you get for the n.
Is n 25?
And it's 25. Very good. Okay, n equals to 25. You should realize that this number, the value of the n, is representing the position. Okay, you can have the first position, second position, third position, but you cannot have a decimal value. You cannot be 25.5. So if you get a number like 25.5, then you know that it's wrong. So 25, you get a value 25, then you know that you are safe. Okay, because the n itself is actually representing the position. So as a position, you cannot have a decimal number. Okay, next one, we're going to look at GP. Okay, 6 geometric progression. Okay, so according to the example I showed you earlier, the geometric progression will be following something in this form. Okay. So geometric progressions is a number that multiply by a certain the same value all the time. So if you have 1, 2, 3, 4, 5, okay. Oh, sorry, I don't look at this number first. Okay, 1, 2, 4, 8, 16. You will realize that the number is keep multiplying by 2. Keep multiplying by 2. But if you look at the number 1, 2, 3, 4, 5, the first one, although it is multiplied by 2, but the second one is multiplied by 1.5. So they are no longer the same. Therefore, this is a GP. This is not a GP. Okay, put them all together. The next term, the following term, will be the previous term times by a common ratio. This one we call it a common ratio. Okay, so because you keep multiplying by the same number. Okay, so if any sequences that actually following this formation, then we say that this is a GP. Okay, next, properties of GP. Okay, so if let's say I let my first term as A, following this formation, and my second term will be A times R times T1. R times T1. Following the formation, I have R times T1. So since my T1 is A, so I will write them as AR. T3, I have R times T2. R times T2 according to the formation. So since I know my T2 is AR, I have R times AR. Therefore, I have AR squared. So if I keep writing a little bit like more, T4, I have R times T3. So since I know my T3 is AR square, R times AR square, then we have AR cube. So over here, you will realize that when you have 2, you have 1R. When you have 3, you have 2R. When you have 4, you have 3R. Therefore, we can actually generalize the formula in the form of Tn equals to ARn minus 1. Are you okay?
Yep.
Okay. Then from here, let me stand a little bit. Okay. Number 8, sum of GP. Okay, sum of GP. So Sn here, as I told you, Sn is read in as a form of summation T1, T2, T3, all the way to Tn. Okay, so according to what we have above, Sn here, the T1 is A, T2 is AR, the T3 is AR square, all the way to ARn minus 2, ARn minus 1. Okay, this time we don't write it them as a reverse order, but I will multiply everything by R. Okay, I'll multiply everything by R. So when I multiply everything by R, I have R as n. This become AR. This become AR square. This become AR cube. All the way to ARn minus 1 to ARn. What I'm going to do next is, this is my first line, this is my second line. I'm going to 1 minus by 2. Okay, I'm going to take 1 minus the first line minus by the second line. So what do I get after I minus them? I have on the left side, I have Sn minus Rsn. On the right side, I have A here. But the AR and the AR here being cancelled off. And the AR square and the AR square here being cancelled off because of the minus. AR cube will be cancelled off with something here. ARn minus 2 will be cancelled off with something here. All the items in between will be cancelled off. ARn minus 1 will be cancelled off. I only left with the ARn minus AR power n. So I have minus of AR power n. Okay, after I subtracting everything, this is what I left behind. So I factor out the common term. Sn bracket 1 minus R. On the right side, I'll also factor out the common term A 1 minus Rn. Then I have Sn equals to A 1 minus Rn over 1 minus R as your final answer. This is how we actually find the proof for the summation formula, sum of GP. Similarly, for P1, your exam can ask for proof. So therefore, if it's happened during exam, you are required to demonstrate exactly the same thing. Okay. After this, number 9, sum to infinity. Sum to infinity. So over here, if R is a number, the ratio is in between of minus 1 to 1, there's something special going to happen. Okay, so when R in between of negative 1 and 1, something actually happened. So what actually happened here? So if sum to infinity means that the n is become very big. So n will be as close to infinity, going towards infinity. Okay, when you have a value of r that is in between of -1 and 1, what's going to happen is this value of r power to infinity will goes to 0 if r is in between of -1 to 1. Okay, this way you can actually easily press calculator. You can actually press calculator to figure out. Like, let's say you can press calculator like the value of 0.5 power by power by 99999. Okay, so if you press 0.5 power by 99999, okay, you will see that it becomes 0. You will press calculator. So when this happen, then we say that the sum to infinity, it become a over 1 minus r. A over 1 minus r. Because of the Rn here goes to 0, you are only left with 1 minus 0. A times 1 is a over 1 minus r. So you will have this formula. Okay, so all in all, this is all the formulas that you're supposed to know for AP and GP. Okay, let's look at the questions now. Okay, let's see what do we have here. Find the sum to infinity of GP with the first 3 terms of this. Okay, so first 3 terms like this, therefore we have T1 equals to 0.5, T2 equals to 0.5 cube, T3 equals to 0.55. Okay, don't jump to conclusion straight away. Okay, trying to write them according to formula first. Therefore this one will be A, this one will be AR, this one will be AR squared. So our purpose is to identify the correct A and the correct R. So the correct A is obviously 0.5. From the second line, I have a 0.5 cube equals to 0.5 times R. So therefore your R is 0.5 squared, which is equals to 0.25. Is it 0.5 square? Is it correct? Okay, it's 0.25, correct. So from here, then only we answer the question sum to infinity. Sum to infinity, the formula is A over 1 minus R. The correct A that we have from here is 0.5. The correct R that we have here is 0.25. So the rest is just pressing calculator. 0.5 divided by 0.75. We have 2 over 3 as your answer. Okay, this will be the questions for A. Question for B. The first 2 terms, this is AP, okay? First 2 terms in AP is 5 and 9. So first 2 terms, so T1 equals to 5, T2 equals to 9. So they already tell you that this is an AP. Okay, so that means following the formation, this is my A, this is my A plus D. Write out the correct A and the correct D. Your A is equals to 5, your D is equals to 4. And from here, what does the question want? The last term in the progression is the only term which is greater than 200. find sum of all the terms in the progressions. Okay, so maybe for some students, they're having difficulty to actually understand what does it mean by the word. So we have a 5, we have a 9, we have so until a certain number. Okay, the last one, the Tn one, it says that this Tn value is greater than 200. Okay, greater than 200. So what exactly is this n? Find the sum of all the terms. Then after that, after you've managed to find this value, have all the information, then they ask you to find the sum of them. So 5 plus 9 plus until Tn. So there are two steps question. This is a two steps question where the first step is to identify what is the value of n first. Okay, we're trying to identify what is the value of n first. So over here, according to the information, Tn greater than 200. Okay, according to what the question states. So I have following the AP formula. So I have a plus n minus 1d greater than 200. A is 5, n minus 1. Then this is a 4 greater than 200. So we were able to find the value 200 minus 5 divided by 4 plus 1. So it should give me greater than 49.75. Because n cannot be a negative, cannot be a decimal number, cannot be a negative number. So n must be 50. Okay, this is a two-step questions. Once I manage to identify that as n is the n is 50, all I need to do is calculate S50. So according to S50 formula, 50 over 2, okay, 2 times A, 5 plus n minus 1, and the D. So the rest is just pressing calculator. 49 times 4 plus 10 times by 25. So I have a 5150 as your answer. So far so good?
Yep.
Okay. Then if it's like that, maybe we should go for the textbook questions. Okay. Let's see, exercise. You have exercise 6C from the textbook. See, 6D. Six E. Okay. this one. Okay, I can see that there are a lot of questions. Maybe we just focus on doing the odd number. Okay, or else will be too many questions. Let me go for the answer. Okay, I think we do up to here. Tomorrow, we can discuss questions, okay, or do the questions together. Okay, I'll stop recording now.